Alright, page 6 of SBAC Review. This question asks about understanding that a function is a rule that assigns an input to an output. An input are x's, outputs are y's. So first we're going to look at this table. They've given us 4 different equations we can look at, and they're calling them functions. We have to figure out which of those functions matches to this table, and only one will. So first of all, we're going to look at our x values and match them with the x values in each of those equations. The reason we're going to do that is to figure out if that x value is true, what y value would come out of that function. So we're going to look at all the y's and see if when we put this x in, that y comes out. So another way you could do this is find the change in y over the change in x and see if it matches the slopes here. You could also, which I recommend, they gave you a y-intercept right here. X is 0 and y is 2. So on a graph, x is 0 would be here and y is 2 would be here. So that is your y-intercept. Notice that these are all in the form of y equals mx plus b. So I know this b value should be 2. This one's not. That one is. This one is negative 22. Nope. This one's positive 2. Yes. So before I've even started, I've eliminated 2 of my functions. Those can't be the matching equations because the y-intercepts are 2. So these y-intercepts match. Now the only difference between these two is this slope is negative 3 and this slope is 3. So let's use our method of putting in an x value and getting out a y value. So when I put in an x value of negative 2, for example, I should get a y value of negative 4. So y equals negative 3, x here is negative 2, plus 2. Negative 3 times negative 2 is 6. 6 plus 2 is 8. Y equals 8. No, y is not 8. So it can't be this one. Let's just double check. Y equals x is negative 2. 3 times negative 2 plus 2. Negative 6 is 3 times negative 2 plus 2. Y equals negative 4. Yes. Yes. So this equation, I'm going to circle this function, is the matching function or equation to this table. Alright, question 2 on this page. Circle which of the following relationships represent a function. Now a function means that there is one input and one unique output. So if the input was, for example, 2, the output was 5. If the input was 2 again, the output should be 5 again. So no matter what input you have, there has to be a unique output. I could get a different input and the output could be 5. As long as every time I see a 2, I get the same exact output both times. Let's see what happens over here. Input 3, output 30, that's fine. Input 4, output 38, that's fine. But the second you have another input of 4, you should see the exact same output of 38, and you don't. It's 21. So that is not a function. And it says circle which ones are a function, so I'm not going to circle A. The set of ordered pairs. So just like in this table, if this x value is 5 and I get a y value of 18, every time I put in that x value, I should get the same y value. This one is 22. Nope, that input does not have a unique output. I'm not going to circle this one. Y equals 5.80x, or 5 and 80 hundredths times x. Well, any input I put, let's say I put in 1. 1 times 5 and 80 hundredths is 5 and 80 hundredths. I put 1 again, multiply again, still going to get the same output. So no matter what input I put in here, every time I put that same input back in, it's still getting multiplied by 5.80, so that is going to be a function. My input table and output table would show anytime I put in 1, I would get the same output every time. In this graph below, well, this is a good example. Input of 4 gets an output of 2. Input of 4 again should also get an output of 2. It does not. That is not a function. Also doesn't patch the vertical line test, you could say. Last question on this page is about bivariate data. On this one, you are a biologist studying bat populations, and you're going to interpret slope and y-intercept in this situation. You are asked to predict the number of bats that will be living in an abandoned mine, and to make that prediction, you are looking for 3 years from now. So that's important information. To start, you find the number of bats that have been living in the mine during the last 7 years. So the starting year, year 0, there are 327 bats. Every year that goes on, it looks like the bat population is going down, 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 down. And you're making a bat population after 3 years from now. So we'll assume that this is now. So you're making a prediction. There's year 8, year 9, year 10. That's 3 years from now. So what's going to happen at year 10 is the question. So coming down here, we're going to graph our data first. Graph our data, which means graph these points up here. 0, 327. Year 0, and we're going to go up to 310, 330, halfway between. That's a difference of 20, so this must be 320. 325 would be halfway again, so 327 is right about here, estimating best I can. Year 1, 306. There's 290. There's 310, so halfway between must be 300. So 306 should be almost 310. And then 299, that's almost 300, so that's just about here. Year 3 is 270, that's exactly on this line, so that's a nice easy point to graph. Year 4 is 254, 260 is here, so 254 is about here. Year 5 is 232. Year 6, 215. And year 7 is 197. Alright, so I've got all these points. I'm going to double check this one. This one looks a little funny to me. Well, that makes sense. This dropped 21 bats. This only dropped 7 bats. So this was unusual that there weren't a lot of bats lost, so this one is a little off of the line. And that's what makes this a scatter plot. It's not necessarily going to make a perfectly straight line. So let's see if I can get a good... I'm not going to always start here. I'm going to try to think about how this line should go. These ones line up pretty much in a perfectly straight line. But this one would pull the whole line up slightly. So I think that's a pretty good representation. This pulls the line up slightly off of all the rest of them. So I'm going to call that a pretty good line of best fit. So I've graphed my data, I've drawn a line of best fit. Now I need to write an equation. In order to do that, I need my slope, I need my y-intercept. Well, I can't find my slope by finding change in y over change in x up here, because these points aren't all exactly on my line. But I can find my slope by drawing a slope triangle. So I'm going to find 2 points. They don't even have to be the points that I graphed, but just 2 points on the line. So I see, I'm looking for easy ones. Like this would be an easy point because it would be exactly 6, exactly 210. This one looks pretty close to about 310. So this one is 1, 310. And I'll find a point way over here. There's not a lot of good easy points here. This one looks about halfway though between 170 and 190, so I'll call that 180. That's 8, 180. So I'm going to find my slope between those 2 points. I've got my y values, change in y. So 310 take away 180 would be my change in y. And my x values would be 310's x value is 1, so 1 take away 8. 300, 130, 140. Nope, 130 should be it. So 130. 1 minus 8 is negative 7. And I can find my unit rate, or I could leave that alone. What this means is that when this is the change in y is the population, and this is the change in x. This is our year. So this means that negative 130 over 7. This means we lose 130 bats every 7 years. So I could find my unit rate, or I could just leave it like that. And then my y-intercept, I can estimate it by looking at this graph, or I could calculate it. So let's calculate over here. I don't really have a lot of room left. So let's go y equals slope, negative 130 over 7x plus, now I don't know what b is. If I were to look at this graph, it's about 330. I'm going to call that good. I could put in my x and find my y, or put in my x and y and find my b, but I'm going to call that good. I'm going to use that equation to make a prediction. So y equals negative 130 for every 7 years times x. Now it says 3 years from now. Well, now is 7. So 3 years from now would be adding 3 to where we're at. So that would be 10 years. So 10 years for my x, plus I started with 330 bats. So negative 130 times 10 is negative 1,300 over 7 plus 330. Whoops, 330. I'll use my calculator for that so I don't make any mistakes. We've got negative 1,300 divided by 7. Got a decimal. Negative 185.71 plus 330 is, whoops, y equals 515.7. Now, I just made a mistake here. I know I made a mistake because look up here. My year is going up and my population is going down. There's no way I'm going to regain all these bats. And I know what mistake I just made. When I typed it in my calculator, I didn't make this negative. So I'm going to do that one more time. 185.71 and make it negative plus 330. So it's really good to have an idea ahead of time of what your estimate of your answer is so that you know whether you're wrong. You can have a good idea that you're off. 144.29. And that looks a little more reasonable. I'm losing about 20 bats a year. So lose 20, we're at 177. Lose 20, I'm at 157. Lose 20, I'm at 137. So that's approximately correct. So I will have about 144 bats. Make sure you're watching the other videos, asking questions, and getting some help if you need it.